So on the periodic table, we always see three bits of information. We see the element symbol, which always has one capital letter. Above that, we see the atomic number, which is the number of protons and number of electrons for an atom. And below that, there's another number, which is typically a decimal that we haven't discussed yet. That number below the symbol is an average atomic mass. It is not a mass number. Typically, the mass number is never found on the periodic table. You usually have to be given a mass number for a specific isotope. What this average atomic mass is a weighted average of the different isotopes that naturally occur for a given element. Most elements have two or more isotopes that naturally occur, and they occur in different percentages. So before we go to the next slide, I want to make really clear that the average atomic mass is not a mass number. Let me make this. Okay, mass number is not an average atomic mass. All right, so how are these average atomic masses calculated? We deal with averages in our everyday life, and we typically just sum values together and then divide by how many values there are. We can't do that for isotopes because they exist in different percentages. For example, if we look at the two most common isotopes for carbon, carbon-12 and carbon-13, they don't exist 50-50%. Carbon-12 exists as 98.89% of all carbon on this planet, whether that carbon's in a diamond, whether it's in your DNA, 98.89% of the carbon is carbon-12. And then 1.110% is carbon-13. We can't just add these two masses together, 12 AMU for carbon-12, 13 AMU for carbon-13, and divide by 2, because they exist in different percentages. So to calculate a weighted average, what we do is we multiply the mass of each isotope by its percentage, and then we sum those values together. So if we have two isotopes, we'll have two products that we add together. Three isotopes, three products that we add together. And those products are obtained by multiplying the mass of an isotope by its percentage. So carbon has two isotopes, so we have two products here that we add together. The mass of carbon-12, which is 12 AMU, multiplied by the percentage that it's found in nature. And these percentages have to be experimentally determined. Our second product is determined by multiplying the mass of carbon-13, 13 AMU, multiplied by its percentage, 0.01110. The two products are then added together, and when we round to two places after the decimal point, we get the average atomic mass. Now, we can tell by looking at the average atomic mass, 12.01, that it's closest to the mass of carbon-12. And so it makes sense that most of the carbon that is found in nature is carbon-12. So we can get some information by looking at the average atomic mass. For example, we can determine which isotope is probably or most likely to be most prevalent or exist in the highest percentage.